Okay, today we're going to finish out 5.5 and start 5.6. So as you recall, we are in 5.5 part 2, letter D. So we are on the back of page 41, and the directions say how many triangles are possible, and we're given this information. So the answer to the question, remember, is there's one, there's two, or there's none. So far in our work last time, we got one that had two solutions, and we got two that had no solutions. Excuse me, I had the hiccups. So let's see what we come up with this time. We're going to need our calculator. Make sure it's set in degrees. All right, here we go. Law of Sines says sine 42 over 22 equals sine B over 12. Sine 42 over 22 equals sine B over 12. So we'll cross multiply. 22 sine B equals 12 sine 42. And then we'll divide by 22. Remember, this is a unit. Do not try to split that up yet. We're going to split that up in a minute, but there's a special way to do that. So that's got to stay like that. So sine B equals 12 sine 42 over 22. Now, we want to know what B equals. The only way to split that is to second sign. So we're going to second sign that fraction. So here we go. We're all typing this in together. So second sign 12 sine 42, close the parentheses around the 42, please, just one parentheses around the 42, divided by 22, and you should come up with 21.41. Now, that's different than our last two examples, because the last two, when we typed in second sign fraction, we got an error message, and that meant no solution. This time, we got a solution. So immediately over to the side, I want you to draw the same original triangle, the original information. So the 42, the 12, and the 22. If there is a second angle, you already found one. If there's a second one, it's 180 minus that one. Always 180 minus the first one. So you get the first one by second sign, and then whatever comes up, that's fine. And then if there's a second one, it's going to be 180 minus that one. So this is going to be 158.59. Now, is it possible to have a 158 and a 42 in the same triangle? No, that's more than 180. So that triangle doesn't work, but that one does. So this problem has one solution. Remember, you can have two, one, or none. We've now looked at an example of all of those. You might have two. If both of these, if this worked, let's say this had come out to be 108, then that's fine, that works. So you would have two for that problem. But because it came out to be 158, that's too much. So you throw that one out, and the only answer is this one. So the question was, how many triangles are possible? The answer is one. That one right there, one. All right, let's try another one. This is problem E. So the question is, how many triangles are possible? We just jump in and do our law of sines. So sine 60 over 9 equals sine B over 10. Sine 60 over 9, sine B over 10. So now I'm going to cross multiply, so 9 sine B. 9 sine B equals 10 sine 60. Divide only by 9. Divide by 9, this is a unit. So sine B equals 10 sine 60 over 9. Now, to get B, I have to second sign. That is the only way to split that. You can't divide or multiply or anything like that. The only way to do it is to second sign. So I'm going to second sign this fraction. So, type with me. Second sign 10 sine 60, close parentheses, divided by 9, close the final parentheses. Enter. I got 74.21. So remember, we had a couple where when we did this, we got an error message. That meant there were no solutions. We didn't get an error message, we got an answer. So immediately draw the same original triangle again. So A is 60, this side's 9, this side's 10. And check to see if the second angle works. And remember, the second angle is always 180 minus the first one. So 180 minus the first one is 105.79. Now, is it possible to have a triangle with a 60 and a 105? Is that possible? Yes, because 60 and 105 make less than 180. That's the rule. Triangles have to have 180 degrees. All three of them have to add up. Over here, these two made more than 180. Can't be. No, that didn't work. This one does work. So both of these triangles are okay. So how many triangles are possible? 2. The answer to problem E is 2. All right, we have one more of these. How many triangles are possible? All right, so while I'm erasing, why don't you see if you can get it set up? See if you can get started on it. So we have 54, 2, and 9. Remember, always when you're setting up your triangles, side A goes across from angle A. So if this is angle A, this has to be side A. That's the way we configure our triangles always. All right, so here we go. Sine 54 over 2. It's always sine of the angle. So sine 54 over 2 equals sine B over 9. So 2 sine B equals 9 sine 54. Divide by 2 and only 2. And then to get B by itself, I'm going to have to second sign that big fraction. So here we go. Second sign 9 sine 54, close parentheses, divided by 2. Uh-oh. Did you get an error message? I did. So what does that mean? That means there are no triangles possible. How many triangles are possible? None. 0 triangles. Because when we typed it in, we got an error message. Okay. All right, good job with that. This process we use when we have a problem that says how many triangles are possible. So let the directions be a clue to you. How many triangles are possible? This is what you do. And when you get an error message, it means 0. No triangles possible. All right, time to move on. Let's look at the next one here. So this is 5.6. By the way, your 5.5 homework will be due. I'll have to look and see when that is. I'll put it in school as you pay attention. Your 5.5 homework. Because we're starting 5.6 right now. So here we go. So 58 degrees, 10, 13, P, Q, R. So this one's a little bit different. We need to find everything missing, so I listed it there for you. Angle Q and angle R and side P. We have to find all that. Okay, well, it's not a right triangle, so what have we been doing? We've been using the law of sines. So let's give it a shot. Sine 58 over P equals sine R over 10. Does that bother you? It bothers me. There's too many variables in that. I can't solve that. When I cross multiply, I'd have a P and a sine R. I can't do that. All right, okay, let's try a different combination. What if instead of using R, I use Q? So sine 58 over P, let's use Q. Oh, wait a minute. Is that going to be any different? I still have too many variables. We cannot use the law of sines on this problem because when I set it up, I have 2 variables in my equation. And I'm only supposed to have, look over here at this one, I'm only supposed to have 1 variable. If there's only 1 variable, I'm good. You can always tell if you have a law of sines problem or not by noticing if you have a pair of information. So in other words, if you have an angle and its side, if both of those are given to you, you can use the law of sines. Look over here. I have an angle, but no side. I have a side, but no angle. I have a side, but no angle. There's no pair, like angle, side. I do not have that pair, like I do in this problem. And because I don't have a pair, I cannot use the law of sines. So, luckily for us, there's something called the law of cosines. Now, I'm going to put the formula for the law of cosines on the board. But there's 3 versions of it. It's long and ugly. And I think it's easier if instead of trying to use a formula, we look at the pattern of the problem. Here's what I mean. If I'm going to use the law of cosines to solve this problem, I'm going to put P squared, that is the side, over here. I'm going to put P squared over here all by itself. And then I'll leave a bunch of space, and here at the end, I'm going to put cosine 58. So notice there's only 1 angle in the problem. Only 1. The law of cosines only uses 1 angle. The law of sines requires 2 angles. The law of cosines only uses one. So when you decide which angle you're going to use, and I don't have a choice, I only have one, so I'm going to use 58, then cosine 58 goes at one end of the equation, and then over here all by itself goes its side. So since that's angle P, that's going to be side P over there. And then in the middle, you always have the same pattern of stuff. In the middle, you have the other two sides squared. So I have 10 squared plus 13 squared. And then minus 2, that's part of the formula, it's always there, times the two sides. And that's the law of cosines. So again, once you've identified what angle you're using, and you're only going to have one, so that's the one you're using, that cosine goes out here on this end, and the side square goes over here all by itself. And then all this stuff in the middle is always the same pattern. It's side squared plus side squared minus 2 side. And that's what's hooked to the cosine 58. We're going to do another one, don't worry. We'll do some more. But first, let's go ahead and figure this out. Now, the good news, the really, really good news is that you can type all of this into your calculator just the way it is. So, type with me, 10 squared plus 13 squared minus 2 times 10 times 13 times cosine 58 equals. So nothing complicated or tricky, you just type in everything you wrote. And it's side squared plus side squared minus 2 side cosine. And that's what you type in. So 10 squared plus 13 squared minus 2, 10, 13 cosine 58. Now, when I did that, hopefully you got the same thing I did. I got 131.22. Now, stop right there. That is not side P. Remember, the formula, that's P squared. So we have to square root that number. So P is actually 11.46. So when you type all this in, don't forget you have to square root it. And that is 11.46. So in your list of stuff that you're supposed to be finding here, you now know side P is 11.46. And the great news is, now look at what you have. Now you have that pair. Now you can do the law of sines. So you can say sine 58 over 11.46 equals sine, is that R over 10. Once you find this side over here, then you have a setup that'll work with the law of sines. So 11.46 sine R equals 10 sine 58. Divide by 11.46 only. So sine R equals 10 sine 58 over 11.46. Look familiar? Sure it does. You want R, so you're going to second sine 10 sine 58 over 11.46. So second sine 10 sine 58, close parentheses, divided by 11.46. 40, that was R, 47.73 degrees for angle R. And I know what you're thinking, oh my gosh, Mrs. Ward, this problem is huge. I had to do the law of cosines, now I'm doing the law of sines, and I'm not done yet. I still have to find angle Q. But it's easy, because now you know two of the angles. And once you know two of the angles, can't you find the last one by just adding them up and subtracting from 180? So it's 74.27. So angle Q is 74.27. If I subtract it right. Wow. That is cool. That is really cool. Okay. I'm going to skip B for just a moment. We're going to jump down and do C, and then we'll come back and do B, I promise. Yeah. So we're going to jump down and do C first, and then we will come back and do B. All right, so let's look at problem C. This is C on page 42. Here's our triangle. And this is 12, and this is 104, and this is 16. And we are finding everything we don't know. So we're finding side E, remember, side E is labeled here. And of course angle D and angle F. Now, if you're going to do the law of sines, okay, so you just got this triangle, the directions say solve it. Sometimes we use law of sines, sometimes we use law of cosines. If you're going to use the law of sines, you have to have an angle and its side. You have to have this pair. I don't have the D's, I don't have the E's, and I don't have the F's. Do you see how each pair is missing something? The D's are missing the angle, the E's are missing the side, and the F's are missing the angle. So this is going to be a law of cosines problem. The way the law of cosines works is whatever angle you're going to use, and in this case it's got to be 104 because it's the only one you have. Out on this end, you're going to put cosine 104. And then that has to equal E squared. So what this right here, these kind of bookend the problem. So on this end, all we have over here on this side is E squared. We're going to put a bunch of stuff in here, but on the end is cosine 104. Now, do you remember from our last problem what goes in the middle here? It's always the same. It's side squared plus side squared minus 2 side. That's it. That's what goes in the middle. Side squared plus side squared minus 2 side. And that's it. Now we're ready to type it in. These are easy to type in. It's not like the law of sines where you have to do some steps. You just type it in. So 12 squared plus 16 squared minus 2 times 12 times 16 times cosine 104 equals, but remember, all that, when you type all that in, is E squared. So you have to square root that. So take the square root of that number, and that gives you hopefully, if I did it right, 22.20. Now you have a matched set. Now you have angle E and side E. So now you can do the law of sines. Sine 104 over 22.2. Remember, you're not done. You got to find all this stuff right here. And so far, all we found is E, side E. So now we're working on the angles. Sine 104 over 22.2 equals sine F over 12. So 22.2 sine F equals 12 sine 104. Sine F equals 12 sine 104 over 22.2. Remember, when you divide here, you're only dividing by the 22.2. So to get F, we have to undo the sign. So we're going to second sign that fraction. Second sine 12 sine 104. Don't forget to close the parentheses after the 104. Divided by 22.2. For angle F, I got 31.63. And once you find angle F, then you're home free to find D, because it's going to be 180 minus 104 and 31.63, 44.37. And there you go. The triangle is solved. On your colored sheet is the law of cosines. Down here, I didn't label it actually. It's right under the law of sines. C squared equals A squared plus B squared minus 2AB cosine C. But of course, those letters are interchangeable, so be careful with that. I prefer just to use the pattern of the law, but feel free to memorize the law of cosines if that works best for you. All right, I promised we'd come back to B, and we're going to. B is a little bit different. I wish you were here so you could tell me what's different about it. But when you look at that triangle, in geometry we call that a side-side-side triangle. Obviously, what do I not have? I don't have any angles. I don't have any angles. So certainly, I am not going to use the law of sines, because to use the law of sines, I need angle A and side A. I don't have it. I need angle B and side B. I don't have it. Or I need angle C and side C. I don't have it. This is not a law of sines problem. The only way you can do the law of sines is when you have this right here. When you have angle E and side E. Then you can use the law of sines. We don't have that here. So, this is going to be a law of cosines problem. Okay? I have no angle, so I'm going to pick one. I'm going to pick angle C. If I choose to do angle C, then on this end of the law of cosines, I'm going to erase this and look here where I have more room. On this is what the law of cosines looks like. I'm going to leave that one up there, just so we can have it for reference. On this end of the law of cosines, it's going to be cosine of my angle. I don't have the angle, so I'm just going to have to call it C. On this end of the problem is side C squared, which is 10 squared, or 100, if you prefer. Remember, when you do the law of cosines, whatever angle you put over here, its side goes over here. So if I had done angle A, then this would be cosine A, and on this end would be 12 squared. All right, so I've chosen C randomly, just arbitrarily. I've chosen C. So this is cosine C, this is 10 squared. Now in the middle, remember, goes side squared plus side squared minus 2 side. So here's the 10 that I'm already using over there. So here are my other 2 sides. So it's going to be 12 squared plus 14 squared minus 2 times 12 times 14. So whatever side is over there, it's done. It's by itself, it's over there. These are the other 2 sides. So in the middle there is side squared plus side squared minus 2 side. And that's what's hooked to the cosine. These are harder to type in. When the variable is stuck at the end of the problem, they're harder to type in. So here's what I suggest you do, at least until you've practiced a few. Let's go ahead and do all of the arithmetic. So 10 squared is 100. 12 squared is 144. You got a calculator, by the way, if you need help with these numbers. 14 squared, I think is 196, but I'm going to double check that one. Yeah. Now, these 3 numbers are times each other. 2 times 12 times 14. So 2 times 12 times 14, that's 336 cosine C. This is all hooked together. So I did my 100, my 144, my 196, and then minus 2 times 12 times 14, which is 336, cosine C. Now, I'm going to move the 144 and the 196 to the other side. So I'm going to take 100, and I'm going to subtract 144, and I'm going to subtract 196. So now I have negative 240 equals negative 336 cosine C. Boys and girls, do not even think about combining the 144, the 196, and the 336. You can't. You can combine the 144 and the 196. That's fine. But this guy is hooked to a cosine. He is a separate term. So I'm leaving him alone. I'm subtracting 144 and subtracting 196. And I did that on my calculator. So I did 100 minus 144 minus 196. And that's how I got negative 240. And these are now moved over. So negative 240 equals negative 336 cosine. Now, remember, I'm solving for this. So I'm going to go ahead and divide by negative 336. So 240 over 336, the negatives cancel. You can take them or leave them. It doesn't matter. I'm just taking them out because they cancel. Equals cosine C. Because I divided the 336 to the other side, all I have left over here is cosine C. Well, wait a minute. How do I get plane C? That's what I want, is plane C. Yep, you guessed it. We're going to second cosine that fraction. And that is going to give us angle C. So here we go. Second cosine, 240 divided by 336. Angle C is 44.42. So in the law of cosines, when I set it up, I'll get this out of here now. This is the other problem. In the law of cosines, when I set it up, here was my variable, cosine C. So I squared this stuff out, multiplied it, and then I moved these two to the other side. So I had 100 minus 144 minus 196. That was negative 240. Equal to what's left, which is this guy right here. Then I divided by the negative 336 so that I had cosine by itself. And then, just like before, the only way to get plane C, the only way to split that is to do second cosine. And that gave me my angle. That's a lot of work, you guys. I know it is. Can't help it. You can do it. It's not hard work. Just a lot. But we're not done. Because if you look, our job, or problem B, is to find all the angles. And so far, we've only found angle C. But here's the good news. What do I have now? I have a pair. So if you want, you can go ahead and set up the law of sines and say something like sine 44.42 over 10 equals sine A over 12. Once I have this set right here, C and C, once I have that, I'm golden. I can use my law of sines. Now, there will probably be some of you that really like the law of cosines. So if that's you, could you do exactly what we just did, all this right here, but use a different angle? So instead of doing it for angle C, could you have done it for angle A? Yes. So if you prefer to use the law of cosines and redo all of this for angle A, you can. That'll work out great. Or if you prefer to use the law of sines, then that'll work too. You have options. The law of sines is less writing for me, so I'm going to go ahead and do the law of sines. All right, so I'll cross multiply. So 10 sine A equals 12 sine 44.42. Divide by 10 only. Erase some stuff here. So sine A equals 12 sine 44.42 over 10. So to get angle A now, I'm going to have to do exactly the same thing. I'm going to have to second sine this time. So second sine that fraction. So let me type that in and see very carefully. Second sine 12 sine 44.42, close parentheses, divided by 10, 57.13. So angle A turns out to be 57.13 when I type this in on my calculator. Oh, but we're not done yet because we need to find all three angles. The good news is, though, the really, really, really good news is that we now have two. So to find the third one, we just know they add up to 180. So here we go. I got 78.45. So angle B is 78.45. Okay? All right, so now you are masters of the law of sines and cosines. I'm going to stop. You got a little bit of time. You can certainly work on some homework. I'll post the due dates, the due date for 5.5. We're not done with 5.6 yet, but 5.5 will be due. And don't forget, we also have our quiz, that little 2-problem quiz over 5.1. So feel free to go back and watch that video, redo the practice sheets, whatever helps you. Hope you're having a great day. See you later.